Okay, this video is to teach Anthony how to go about to rekey a Schlage AL series lock. And what we're going to start with is, Anthony, I'm going to say several things that are not going to be important in the sense of the task at hand, which is how to rekey a lock from a company by the name of Schlage. Walter Schlage patented a very important seminal lock, a lock that was first of its design in about 1921, and Schlage has been an outrageously successful company for basically the last 100 years. The history of Walter Schlage is that he was of German descent. His father, I believe, was an engineer. The son became an engineer, highly mechanically inclined. And as a result, I think he actually worked for a lock maker back just during the World War I era. And then at night came home and worked in his basement and created locks, built locks. And he actually put together a lock that was unique in the sense that the cylinder itself was contained within the trim, and that was new for its time. After several improvements to their work facilities, growing larger, acquiring companies, Schlage is probably the leading manufacturer today. This lock that we have here, this AL series lock, was probably brought onto the market mid-1990s perhaps. I don't really remember. This lock has been around for sure for over 20 years. And you're going to learn how to go about to take the keys that operate the lock when they come from the factory, and you're going to learn how to make a different key work that lock. Okay, so there are a lot of things that I'm going to say, and I will tell you when I'm going to say something that is important. I will say this is important. Okay. Okay, so we're going to take this lock and we're going to rekey it from the keys that come with it to a different key altogether. Now, there are lots of lock manufacturers, and all of the lock manufacturers have a very particular system. And what happens here is, this is a Schlage key. We know that by, and remember, when it's important, I'm going to say this is important. We know that it's Schlage, it's because it's marked Schlage. The bow of the key has a distinctive shape, that is the Schlage shape. There would have been a design patent originally on the bow of this key that would have protected Walter Schlage or whomever from anyone else manufacturing a key that looked like this.
Okay.
For so many years. I don't know how long a design patent is good for, but maybe 9 years or 7 years or whatever it is. He then would have had a utility patent on the keyway. The profile of this key is very particular. When you look at the grooves, these are called milling. This is a milling. The milling profile, exactly all of the dimensional properties of this is the Schlage keyway, the Schlage C keyway. This happens to be marked C, and this is a part of the Schlage classic obverse keyways. There are 7 of them. Okay. This is the most common one. If you have a key on your key ring, it's probably this or a quickset keyway. So the design patent and then the utility patent would have been on the keyway. I believe it's a utility patent, protecting anyone from copying that keyway for so many years. Now, you can go to any big box store, home improvement center, and get this key cut. It's not protected. It's not patented. There's nothing protected about it because those patents have long run out. Yeah. So anyone can copy this key now legally. This key and all other this key, and let me back up. This key has numbers on it. That's called the bitting, as it pertains to this key. It's the code. This is called direct code. That means that you can look at the key and say, okay, I can directly see what's on there, and that will relate directly to the features of the cuts of the key. Other keys, this is a clone copy. this happens to be a Kaba Ilko blank, you'll notice that it, for all intents and purposes, is the same bow.
Yeah.
Okay? It doesn't say Schlage on it because it's Kaba Ilko. They have their... They have their marking on the head. It says USA. That's all it says. This is a look-alike clone key blank for purposes of this video. Now, you can have the codes on there as a direct code. You can also have codes on there that are an indirect code.
Okay.
They're nothing other than a code that tells someone to go to a reference document to say, pull up this number in the code book, and it will then tell you the information about the cuts of the key. There can be a blind code, meaning there is no information on it at all. Okay. Now, every manufacturer of locks, or every system, as you can see from the underside of the lid of our pinning kit, and anyone who's watching this familiar with a pinning kit, we've got Sargent, Weiser, Kwikset, Schlage, Yale, Arrow, Westlock, Corbin, Russwin, DH and Z class, Corbin Z class, Russwin DH class, and Corbin X class. So what that means is you've got different manufacturers here. The bottom line is, and this is important, the dimension from the shoulder of the key blank, the shoulder, when you put the key in, that's what it stops against the face, to the center of each cut, the dimension from the shoulder to the first cut is specific to that manufacturer. The center to center of each cut is specific to that manufacturer. If you were to take the shoulder to the first cut center, the center of that cut to the depth of it, and cut it to a Sargent specification, it's not going to fit in anyone else's lock. Not only because the cut's in the wrong position, but it's the wrong keyway as well. So what's important for you to understand is the placement of those cuts on the key blank, as referenced from the shoulder point, is unique to every manufacturer. Think of it this way. A starter from a Ford is going to do the same job as a starter on a Chevy, but they're not compatible with each other. You can't take a Chevy and put it into a Ford.
Right.
Now, it's important that you understand that. The key that we're going to change the lock to is this particular bitting. The bitting of this key is a particular dimension from the shoulder to the first cut. We don't care about that dimensional property. We could pull up what's called a depth and spacing chart, and it will tell us Schlage's first cut from the shoulder to the center is such and such dimension that you would measure with a caliper.
Yeah.
It would then tell you, that same chart would tell you, what is the center to center dimension. The shoulder to the first cut is not the same as the center of each successive cut. You can pull that data up. Once you know the shoulder to the first cut and then the center to center cut of each cut, and if you know the depth, you could literally put this into a vise and file file the key blank with a file using your caliper, create a key. If you knew the code and you had that depth and spacing chart data. The point of all of that is, when you look at a key, you don't think much about these cuts, but there's all that science behind it. Now, we're going to deal just with Schlage. The key that we're keying this customer's lock to is a key that they use all the time. It's 32322. Now, if you study that, the first cut is closest to the bow. This is the bow. It rhymes with toe. That's the tip. Other lock systems are referenced from the tip to the cut. In Schlage, it's the bow to the tip. The first cut is the first one from the bow. 1, 2, 3, 4, 5. There are 5 cuts. There are 5 valleys. Would you agree with that? Okay. Would you take a look at that key and tell me how many are on that key?
6.
Okay, so now you have a 5 and a 6. You have a 5 pin and you have a 6 pin. There are 4 pin. There are 7 pin. There are all these different systems. Schlage utilizes either a 5 pin or a 6 pin system. Okay, that's how many cuts are on the key. Now, that key is just here for example only, really. Now, if you take this key back and you study this key again, let me have that one. That code is 32322, and I'm going to write it down. 32322. What's a bigger number, 3 or 2?
3.
That happens to be a deeper cut.
Right.
Can you study how the first cut is deeper than the second cut?
3, 2, and then go back to 3, 2, 2, yeah.
Very good.
I see it.
Now, take this key and using the bidding that is on the key blank, what are the first two numbers?
3-3.
On the key blank, on the head?
Oh, 5-5.
Okay.
So
do those first two cuts look the same depth?
Yeah.
What's the third cut?
2.
Does it look shallower?
Yeah.
Okay.
6 deeper. 4s. Yeah.
Now you're armed with a lot of information. Now, if you look at the Schlage chart, what's the first number? 5, you said?
Yeah.
Okay. That means that it has a depth of cut of 0.26. If I were to take my caliper and measure from the root of the blade to the depth of that cut, it ought to measure 0.26. And I measure, and it's not exact. It's about 261, 262. The root to the bottom of the cut is 260. This measured 261, 262. Right. Now, what's the bottom pin dimension? 0.24. If we wanted to use a number 5 pin, we're looking for a 0.24, and this happens to be a 0.24. Doesn't matter. What's 0.26 plus 0.24? It happens to be 0.5. Don't have to worry about doing the math in your head. That is the effective plug diameter, which we'll talk about in a moment, to the cylinder. The 260 and the 240 are directly related. Right. When we talk about the depth of the cut, a locksmith is going to talk about the depth of the cut, because when they put a caliper on it, they're going to measure from the root to the depth of the cut. Okay. But when we're pinning locks, we really don't care about the depth of the cut. We care about how long of a pin we're going to put in there, and that's what the pin kit's for. Okay, that's a lot of information that you just simply don't need. However, it does give you a background in terms of what we're dealing with. We are doing a Schlage system. We will only be paying attention to the Schlage chart. You know that your bidding is 32322. Those are the only numbers that are going to really matter. Now, none of that matters just yet. Let's take a look at this lock. What you first have to learn how to do is you have to learn how to disassemble the lock. So when you are doing a job for a customer and you're going to be keying about 60 or 90 locks in the next 2 or 3 weeks. So you're literally going from no knowledge of what a lock works, how a lock works, to repinning locks, and you're going to be doing it dozens of times over the next couple of weeks. Now, if you study the key that came with it, there are hardly no cuts on that key.
Yeah, no.
Okay. If you were going to guess, based on your knowledge of these cut depths, would you say that that would be a 1 or a 9?
This?
No, that, yes.
A 1.
It would be a 1.
Right.
And a 0 would be no cut. So
right.
we call that one-bitted.
Okay.
That means that in the cylinder of the lock, there's nothing but 1 pins. Why do we do that? We order them that way because we can then take that key blank
and make it whatever we want.
Turn it into whatever the client requires. In this case, 32322.
Right.
Okay. So rather than the factory send us keys that are already cut, and then we have to cut a whole bunch of keys, we order them one-bitted and recut the keys that the manufacturer sends us. So now we get into how to work on a lock in particular. Now, and we're going to go over this off the video, but whenever you are putting together a lock job for a client, you're going to always make sure that the box contains all the parts necessary, that it has the lock, it has the keys, it has the latch bolt, it has the strike, that it has the screw package, it has the paperwork, and any other tools necessary for the client to be able to successfully install it. And you'll do that when we are actually working on keying locks. Now, a lot of background information, not a lot of it matters. Right now, we're going to talk about things that do matter, how you're going to sit down and start keying this. The first thing that you're going to need to do is to disassemble the lock, and you're going to need this little ice pick, downy pin, screwdriver that has been ground down. This is a tool that will allow you to, by using the key, disassemble the lock so that you can gain access to the cylinder itself. So the way that this lock works, and many others, is that you insert the key, and even though it's one-bitted, it doesn't matter, into the cylinder, and then you turn it clockwise. You turn it clockwise. That's all you do. You can turn it counterclockwise or clockwise. We turn it clockwise. Maybe it's a result of being right-handed. I don't know. So you'll insert the key. The goal is to remove the lever and its cylinder from the lock. If you go up to a lock and you pull on it, the lever doesn't come off, does it? It's not supposed to. If I lock this lock, it's locked. There's no way to get that lever open. In order to get that off, you have to insert a working key, and there's other ways to do it as well. You could disassemble the lock from the inside and get to the cylinder and open it that way. We have a working key, so life is easy. You insert the key and you turn it 90 degrees. And it's difficult, of course, to do it on the camera. But in this little hole is the spring-controlled tab that when the key is turned 90 degrees will allow us to depress.
Okay.
When the key is not in there, I cannot depress that tab. I need to depress that tab in order for us to be able to, I'm going to hold on to the rest of the lock, depress that tab, and I can tell that I've been able to successfully pull the cylinder off. The lever and the cylinder are now in my hand. All of this, you simply put back in its box. At this point, you will remove the key from the cylinder, put that down, you save those, then you will remove the lever, and now you have the lever insert, very important, this has to go back the way it was, and now you have the cylinder.
How was that?
What is it?
Yeah.
This lever insert is a piece of equipment that allows the cylinder to stay in place in the back of the cylinder. Without that lever insert, it's just going to move around. I don't want the cylinder to move at all in the lever. Without that insert, it would flop around. So that has to go back inside of there. Now, you've got a cylinder here. That's great. We've got a cylinder. Now what the heck do we do with it? So we've got an operating key that works really smoothly. Okay, no problem. Now you're going to notice that the tailpiece, this is called the tailpiece. That's called the retaining cap. It's a threaded cap. There is a retaining pin in there. There's a spring inside of there. This is called the cylinder plug. This is the housing. This is called the Bible. Yes, a Bible. It's called the Bible. Inside of here are going to be bottom pins, driver pins, and springs. Hopefully you never get to meet the springs and the driver pins. And we'll explain that when it does come to pass. So the way that a key works is that when the length of the pins match the depths of the cuts, you create what is called a shear line. Shear. The word shear, as in shear, like in a earthquake, where ground will shear, move in shear. Shear as if you can see through something because it's sheer, like curtains. But shear relates to this sort of principle, moving across each other in shear. A key does not work, will not work, because the length of the pins that are in front of this kit, that are in front of us in this kit, do not line up with the depths of the cuts. Only the length of the pins that line up to these cuts, and those are cuts. They happen to be one cuts. When I insert that key, all the pins are now at shear between the plug and the Bible and the cylinder housing. That's what will permit a key to turn. Now, the best way to demonstrate that is to use a tool, a capping tool that Schlage manufactures. This is a costly tool. Do not drop it. The reason you don't drop it is all these little teeth that are on here, when they hit the floor, it'll get damaged. The way that this works is, and you don't have to use a capping tool. I do because it's a lot faster. You insert the capping tool, and what you're doing in this principle, and I'm going to not do it here just to show, you're going to depress the spring-loaded pin that's here. Can you see the pin? Okay. You're going to depress that, and then I'm going to unthread the cap. As I'm holding the pin down, the pin has a spring in it. I'm holding the pin down as I'm unthreading the cap. How you go about putting this back together is up to you, but this is how it's done. Be mindful, the tail piece is vertical. That's very important. Because, threaded cap off, you can put this tail piece back on horizontal. That's going to result in the lock not working correctly. You'll be able to get the lock put back together, but you'll be able to never pull your key out. Has to be vertical on lever locks. This tailpiece has that bird's mouth preparation on either side because they can obviously use this in other locks. I mentioned that there was this pin and a spring. There is a spring. Those are going to come out every time you do this job. Now, here's where the fun stuff starts. This tool is called a plug follower. What did we call this? Don't overthink it. It's a plug.
Okay.
It's a cylinder plug, cylinder housing. The cylinder plug and the plug follower and the cylinder plug kind of go together. The way to do this is exactly as follows. Don't overthink it. Don't do anything different. This is how you do it. Insert the key. Rotate it about 15-20 degree, just slightly.
Okay.
Don't overthink the degree, but just slightly. Maybe 30 degree, something like that. Then, this plug follower has a couple of preparations in it. That's for a different type of lock or a different cylinder prep on the back. You have to make sure that this round portion here is directly positioned like this every single time. The key is turned at about 30 degree, maybe 45 degree, whatever it is. Now, what I've done is I've taken the pins and I've brought them to shear, and now I can rotate the cylinder. If I were to pull on this, the plug will come out. But what will also come out are the springs and the driver pins.
Okay.
The reason you use a plug follower is because you want to keep the driver pins and the springs in the Bible. Yes, sir. So at this point, what you have to do, and the key is touching the inside of my finger because I'm controlling it. I'm then going to push. This has to be directly in line with the Bible.
Okay.
Actually, what I'm doing is sliding the housing over my plug follower. Now, two things are happening here. You see those pins?
Yeah.
Would you say that they are even with the top of the cylinder plug? Would you say that they're flush?
Flush.
Would you say that they're shear? They are in shear because it allows the cylinder to move. That's what a shear line looks like, when all the pins are flush or even. If we put in our other key, there are no pins that are flush or even. It does not satisfy the requirements of the shear line, and it will therefore not turn because
they're not shear.
They're not shear. What's up in here is this driver pin, and there's a spring inside of the Bible. A driver pin and the spring. You can't really see it on the camera. I will pull it out just slightly, and you can see just evidence of it poking out. If I were to pull that plug follower out, that driver and spring are going to pop out because there's a spring in there. Now, the reason this key will not work is the driver is pushed down into the hole, and there is no amount of force that you can generate to turn on this key to make those pins shear.
Right.
The key will rip before that happens, even one pin. That's why a key will not work in a cylinder, because the driver pins are sitting in the plug. Now, you don't want to mess with this. You always want this end of the plug follower to be the front of the cylinder. This other end over here, don't worry about that. That's the funky end. Okay, now what you're going to do is these pins, they're all number 1 pins. You can take them for this time and dump them in our box.
Okay.
This is a 6-pin cylinder that we're going to put a 5-pin key into it. In the back, the reason this is the front of the cylinder plug and this is the back is because we have to drop the driver and its spring. It came with a 6-pin. There are drivers and pins in each of the 6 chambers.
Right.
We're only pinning it to a 5-pin key. If I didn't remove that rear 6th driver and spring, what would happen as soon as we put them together, this is going to flop down into the 6th hole.
Okay.
That has to come out every single time, because we're only doing a 5-pin system. Because that lock came with a 6-pin key, if the lock came with a 5-pin key, you wouldn't have to do it, because there would not be a spring and a driver pin in that 6th chamber. With your X-ray vision, 1, 2, 3, 4, 5, 6. There are 6 holes in here. You can see the 1 hole from the back of the cylinder right there. There are 5 more in there. That hole that's right there. Now, the reason this is the front of the plug follower is because, and the front of the cylinder, is so we can never get it confused. You don't want to put it back together this way. This is the front. At this point, you know that your bidding is 32322. We have it written down. Now, put the key in, using your chart of your bidding number, the first number in the code is the one closest to the bow of the key. I want you to load 5 pins in here that are 32322.
Okay.
Now, Schlage 3 translates to this. If I put my caliper on a 3-pin, it's going to measure 0.210 inch.
Okay.
You're going to find yourself a 0.210 pin. Don't any of the ones that say T, ignore those. What did I call? I call these drivers, but you could also call them top pins. T stands for top. I don't know what Lab calls the C. I'd call it a bottom pin. Now you'll take note, because we do so much Schlage, we put cheat sheets in here.
Okay.
So find a 210. It starts over here with the small one, and like a piano, it just gets bigger as it goes along.
210.
Now what's the little cheat sheet number there?
C.
No.
210.
What's in marker?
3.
Uh-huh.
Okay.
So Terry made life easy on us.
All right.
Put your 3 in there.
Oh.
Do not mix the pins.
Yeah,
they are
that's...
color-coded for a reason. The pointed end goes down. Does that appear to be flush?
Yeah.
Put in the rest of your pins.
It was what?
3, 2, 3, 2, 2.
3, 2.
I'm going to write it down on this box.
3, 2. Oh, there we go.
The first hole is chamber 1. The 6th hole is chamber 6. We're doing a 5-pin key, so we're only dealing with 5 chambers. That means that the very last hole
It's
should
flush.
be empty.
It's flush too.
Okay? Now let me take a look at it.
Sure.
And I can tell you, based on my experience, that this is going to work perfectly.
Okay.
Now what you do is you put this back into the cylinder the same way you took it out, on about a 45-degree angle. The reason you must put it on an angle is because if you put it straight on, that first spring-loaded driver is going to hit that empty hole, and it's going to fall in, and it's going to seize the cylinder. And Terry's going to have to fix it when you do it.
Okay.
On an angle. We're on an angle. And then we're just going to push. See that?
Mm-hmm.
It's on an angle.
Yeah.
It's on an angle. You can't easily see it, but it's on an angle.
Yeah, that's perfect.
You're going to push that all the way through consistently.
And then
I'm still on an angle. I should have been a little bit further away. Bring it to vertical. Take your key out. You have to be really careful taking the key out when there's no threaded cap on, because I could pull this right out right now, and all my drivers and springs are going to come out. Do not drop the plug follower.
Right.
All of this is important. You don't want to damage it. So it works super smoothly. I take the key out, and what you'll notice is I'm using the tip of my index finger against the face of the cylinder plug, and these two fingers, the middle finger and the thumb, are pulling the key out as I'm pushing away this way, pulling back this way.
Mm-hmm.
I can then test the key without pulling it out. Works perfectly. Now put your spring inside of there.
Just right inside of you?
Yep. Nope. Yep. That hole. Put your pin in. Now study the pin. Both ends appear to be the same, symmetrical, so put it in either way that you want.
Okay.
And when you're working, you want to work over your table so that when that
Yep.
little piece falls, you'll be able to find it. Put your tail piece back on. Work with your cylinder vertically oriented.
Okay.
Vertically oriented. I can't really see that on the camera. Do that there.
Okay.
Put your tail piece on first. You can only go on 2 ways. One is wrong, one is right. Put it on any way that you can, and then confirm that it's vertical.
It's vertical.
It's vertical. Put your threaded cap on.
Okay.
You want to be careful not to cross-thread anything, but the truth of the matter is it's not going to go far at all because you have that spring, that pin sticking out. So at this point, you have to take your ice pick, depress that, hold it depressed as you get that cap. I'm doing it without being able to see it. I'm turning it backwards to get it seated properly. Now I'm off.
There you go.
Yep. I'm going to go all the way down, and the way my dad taught me is you go fully tight, then you back it off one hole.
Oh, okay.
You seat it. If it's fully tight, the key won't turn smoothly. If you back it off one hole, it'll turn smoothly. Put that in there, make sure it works. Would you say that that works very smoothly?
Yes.
When you have the cap back on, you don't need to use this
To push.
to push. You can just pull the key out.
There we go.
Yep. It's a brand new lock, a brand new key. It will be a little sharp. It will be a little... put it back in there and make sure it works. The analogy I like to use is imagine a gentleman comes home, maybe he's not a gentleman, comes home drunk, and he just wants to get in his house.
Not a gentleman.
Those keys got to work smoothly because you don't want him to kick his door down.
Right.
Let me test it and make sure we're in good shape.
Go ahead.
That is your first cylinder that you've keyed, and it's the fundamental of how a pin tumbler cylinder works. Tumblers. Tumbler is an important word. That is a pin tumbler. Those look like pins. There are other tumblers.
Yeah.
There are lever tumblers. There are disc or wafer tumblers. Different formats of locks. Linus Yale Jr. Brought in 1851 the pin tumbler cylinder that we all use today every day, 170 years ago. Linus Yale Jr. The Egyptians basically invented this type of cylinder construction 4,000 years ago.
And we still use it today.
And it must be that Linus Yale Jr. did research and saw the Egyptian design. I never read a book that said he copied the design or improved it, but the similarities are so great that if I showed you the Egyptian lock, you'd say, oh my gosh, it's the same principle.
Right.
And it is. Now, all we have to do is put this lock back together. The cylinder will go back into the lever. Our lever insert must go back in.
Oh, here we go.
I've only dropped two things, not bad.
It's all right.
That'll go back in the way it was. At this point, you put the key into the cylinder, and you can kind of use it as a handle. All of this has to now go back down onto the lock, the way you took it off, and it will only go so far.
Okay.
You can't push it any far. What did you do to take it off? What did you have to do?
Unlock it, right?
It does not have to be unlocked. But what did we have to do? It's okay that if you don't remember. What did we have to do to get that lever off? We had to turn the key.
Yeah.
To put it back on, guess what?
Turn the key.
Yeah, I got to turn the key. Now, the reason that this works is you're going to notice inside of here there is a horizontal slot.
Yeah.
What's the orientation of that tailpiece?
Horizontal.
It's horizontal.
Yeah.
You put it this way and it's vertical. Doesn't matter vertical or horizontal,
Right.
but it has to be this way. If you put the tailpiece on the wrong way,
It's not gonna go.
you could force it to go in there when you turn the key, but it's not going to work right.
Okay.
Now, that tab that we depressed, there's the horizontal slot back down in there. That tab that we depressed, see how it can move? And look inside of there, how it moves, that C-clip spring,
I see it.
how that moves. The reason you can't just pull a knob or a lever off is because that C-clip and its tailpiece are oriented like this. I can't push the C-clip, the tab in because it's blocked. When we insert the key into the lock and turn the cylinder 90-degree clockwise, I now have enough room to push that tab in. When I return it back, I can't push it.
Right.
That's how that works. In order to put this back on, you do have to have the key turned because you need to make room for that C-clip to move.
A little bit, yeah.
I'm going to turn it. I'm going to push it. I heard it snap and click.
Yeah.
I'm going to take the key out. If the key comes out, that's a very good sign.
Okay.
I'm then going to pull on it, and I'm going to observe that that slot is present, is visually present in that hole. It's visually present in that hole. If it wasn't, it would look like that. You don't see the tab. You do not see the tab there. Now I see the tab. Now I see the tab. It's just
Yep.
the metal that's there. You've just been taught how to key this Schlage AL53 lock, the principles of the system of Schlage, and while there was too much information necessary, I think it's a good background to understand, to demystify what exactly happens inside of a cylinder. It's really simple. Now, in 1851, when Linus Yale came up with this system, and since 1851, the cylinder has mostly remained unchanged. However, there have been outrageous, substantial evolutions to the cylinder to impart to it extreme security, extreme pick resistance, resisting methods of bypass, making the keys all but impossible to receive if you are not the right person. You can get this key cut at someone who is a shoemaker. He can cut a key for you. But protected keyways, restricted, high security, has taken the same thing that the Egyptians invented 4,000 years ago, that Linus Yale Jr. significantly improved 170 years later. The principle remains the same. As I was taught by Chris Chase at Aloha, certified registered locksmith, an instructor, a lock is a blockage, and a key is the removal of that blockage.
Right.
In our system, the blockage is the pin tumbler. When we insert the key, it removes the blockage. It's that simple. The principle of a lock is there's a blockage and the key removes that blockage. A key can be anything as long as it removes the blockage.
There you go.
Now, tomorrow, you're going to start keying all those locks that are there. On Monday will come another 30, and then the week after will be another 30. Do you have any questions?
No.
You have to ask at least one.
We're always going to be working with what is it?
Schlage.
Schlage, always.
No.
No.
Your job for this client is exclusively Schlage, though.
Okay.
I might hand you a quickset lock someday to key.
Okay. And then you've only numbered Schlage though, right?
Yeah, we only put Schlage numbers inside of there.
Okay.
Because that's the only system that we really kind of do, or that this kit does, I should say.
Yeah. That makes sense. There you go.
I do expect that much of this will be forgotten, especially the mechanics of how to go about disassembling the cylinder and how to put it back together.
Okay.
But we're going to go over that. You're going to make several mistakes. You're going to do several things that will frustrate because you'll lock and seize the cylinder up and we'll have to get that taken apart. But you do have to explode a cylinder to learn how they work.
Okay.
All right, we're going to end this. Thank you very much for coming by.